Scott?
Ready as it's going to get.
You ready? Okay, so Scott is going to give this thoroughly researched and heavily prepared presentation on JTAG, whatever that means. I didn't say anything about it earlier, so I don't know what it is offhand, but it'll be very interesting to see what we can do with this and just how it can help us. And with that, I stop babbling, and Scott, the floor is yours.
Okay, well, thanks. I appreciate the opportunity. So my name is Scott Gibson, for those of you who don't know me. I love working on robotics and building them and playing with technology. I do this for a living, so I kind of have a unfair advantage sometimes, I think. But so that's why I wanted, this talk was requested. Basically, how do you debug an embedded program? You know, I've done it a number of different ways, and you've got to have, you know, the ability to debug it, or it just gets so frustrating to do anything. So we're going to talk about JTAGs, and specifically I'm going to demo the platform that I use for development, a tool called VisualGDB, which is a plugin for Visual Studios. It is something you have to purchase. It's not open source, but it's fairly reasonable. You can get, and we'll look at it here in a little bit, you know, it's less than a couple $100. So for what you can do with it, to me, it's really a no-brainer, because you can use the same IDE, which is Visual Studios, which is one of the best editors I've run across, both with IntelliSense and some of the debugging stuff that you can do. So that's where this talk came from, and I'm going to apologize up front because this was kind of put together a little bit here, a little bit there, a little bit here, so it may not be there all that cohesive, but hopefully I'll get the point across. So like I said, the overview, I kind of went over. We're going to use VisualGDB as a Visual Studios plugin, so that we get all the Visual Studio Editor stuff. And I know it was published, links to downloading this stuff and installing it, if anybody wants to follow along. I know it was posted online.
Posted on the DPRG.org website.
So JTAG specifically, joint action test group or action group that basically the powers that be came together and said, well, we need some sort of standard that across all platforms we can kind of leverage this technology for development. So that's what they did. And it also uses, there's a lot of different forms of what people call JTAG. There's what they call BDM, which is background debug module. It just depends on the chip and the families that you're working with. But you also have these on FPGAs and CPLDs, so it goes a lot further than just microcontrollers. And basically a JTAG can give you access, like sometimes in production we'll use a JTAG to actually program the chip, right? So it has more functionality than just to debug. And that's one of the first steps that you're going to do before you debug, right? You load your code on the chip. Well, this is how that gets done. The example Mike just showed us, you know, everything was done over SSH. And when we get to the Pi version of the presentation, that's what we'll use. We'll use an SSH socket to actually access the GDB debugger. That's pretty common on a Linux platform, that you would have a GDB debugger. And basically the SSH socket's going to tie into that as well. So it's not necessarily hardware specific, because the JTAG for an embedded platform is hardware specific. This is the JTAG that I'm using for this particular platform, and we'll get there here in a minute. Yes, sir.
Never mind. You're good. Go ahead.
All right, so basically we use a couple of pins on the microcontroller, and these pins are dedicated to this function. So it's not like you can just reuse that pin for something else, right? So you have to have the hardware access to it, to those pins. And so it's been around since the 80s, so it kind of grew up with microprocessors or microcontrollers, because back in the days of the 8031s and some of the early microcontrollers, there was no, you burn it EEPROM and you plugged it in and you prayed it worked, And then usually on the test stands that I messed with years ago is you had stacks of EEPROMs, failed programs. And you're developing an assembly and you had no ability to set breakpoints. So it was frustrating. It's much easier today for sure. So this is an example. This is actually an example of this interface right here on this interface board I have. And you'll see that it's just got the TMS, TCK, these signals right here. I don't know why my mouse isn't working there. Oh, there it goes. All right. So you got the signals for the JTAG. This one happens to be a 10-pin. That's one thing that's not really standard on the JTAG interface. These signals, you'll always see these signals, TDI, TDO. It's kind of like a SPI bus where you have synchronous data and it's clocked in and out. And again, the connectors that they use can be all over the place. The pinouts are not standard. This is all JTAG and more or less family specific. So this pinout right here that you see on this print is specific to ARM parts. Doesn't matter whether it's ST part or NXP part, they all follow this connector convention. So within certain families they are defined, but like this can also be a 20-pin connector, which is another standard they have for ARM. And basically with the other pins, what they'll do is they have what they call trace functions. So you can actually trace code, and you get a step-by-step view of what the program's actually doing, where it's going. So basically when you look at a conditional statement, you'll see where it's jumping to, kind of thing. So this is basically a lot of the hardware side of it, which isn't super interesting, but it's important to know so that if you do invest in a JTAG or you do buy a board, you know what kind of connector you need for that JTAG. So now we're going to talk a little bit more about specific JTAGs and how it varies from family to family and things, terms that you'll run into and things that you probably should know about them. So anyway, some of the ones we're going to hit today is the ST-Link, which is the one I'm using for these boards here, this nucleo, I can't speak. And I'll talk a little bit more about that platform. I'm really impressed with it. It's cheap and powerful, but we'll get into that a little bit more later. So that's why we're going to cover the ST-Link. There's also vendor-specific JTAGs, things like, and I have examples of different JTAGs here that I've run. Like this is a Renesas, which now Hitachi JTAG, and it only will work on their chips. Some of these other JTAGs will, like this one will only work on ARM family chips, but it doesn't matter what family it is. And you notice that it's got the 20-pin connector and the smaller connector. Here, I can pass these around if you want. And then these are some other ones that, one of the main, if you will, one of the better ones is made by Sager. So this one is made by Sager. It's a professional version. This is what they call the educational version. So it was a lot cheaper than the professional version, but every time you go to run a program, it pops up a window. You're using an educational. You have to say yes. So it gets to be kind of a pain in the butt. But that's another one, and it's another example of how the different connectors can happen. And this is my one from work. This is a $600 one, which it really doesn't make sense why it's so much more than some of the other ones, because it pretty much works the same.
Because they can charge it for commercial.
Yeah. Well, yeah. But what my point of bringing this up is be careful. Not every JTAG is going to connect to every board, right? And not every JTAG is going to be supported by a particular IDE. So some IDEs, like for instance, this U-Link right here, and that's why I passed it around. This is from Kyle, which makes it, years ago, the Kyle and UVision was one of the main IDEs that you would use commercially for development on ARM parts. But this JTAG will only work with UVision. So the software interface of the driver is completely different. So that's why, I mean, it's pretty much the same as those ones. Yes, Carl?
So can I ask, so back in the day when I used to do hardware, way back in the day, so I always thought of JTAG as something where you'd have multiple chips and they were daisy chained from one JTAG port to the next. And then that way with a single connection to the board, you could access the peripheral registers of any of the chips on the board through just one port. Is that still the case?
Yeah, that's called JTAG chaining, yeah.
JTAG chaining. But then, like for today's talk, are we
We're not
focused-
going there.
We're just going like a single chip at a time?
Yeah.
Okay.
Yeah. I mean, that's a good point, though. I mean, this is just kind of the introductory information to JTAGs. There's a lot of things they can do, and especially some of the more professional ones, the more expensive ones, basically. You know, they can do a lot of different things. Like, for instance, I have it's a Lauterbach, which is a German company, and they make a series of JTAGs. And you can, I know the company I work for is probably, you know, each JTAG that we've had to buy from them has a module and a cable, and they're both about $6,000 a piece. But I can also take an existing platform and I can use that tool and I can step through the OEM's code that's running on that chip without having the source code.
Oh.
So that's one of the tools we use for debugging and for reverse engineering quite a bit.
Interesting.
So yeah, they get, and that's what I mentioned earlier, is there's other interfaces besides just JTAG. There's BDM, there's another one, because BDM is background debug module, and that's a PowerPC thing. So on PowerPC chips, you have a BDM board.
Scott,
Yes,
you
sir.
mentioned one that, you know, you kind of gave the super upper bound of one. What's the lowest price JTAG?
These little JTAGs here, and we're getting there.
Okay.
I'll tell you what, Doug, let me answer your question with the next slide.
Gotcha.
Wow. Saw that coming. Way to go.
So some of the differences that we've been talking about, and to answer Doug's question, the one that I'm using right here, this one right here, is $11.70 from DigiKey. Now the ST, the professional version ST one, is $35. But the issue you have to watch out for with vendor-specific JTAGs is this will only work on STM parts or ST macro parts, right? So it can be a Cortex M3, M4, it can be any of that family, but if you go to like an NXP chip or a Hitachi chip or a different chipset, then you got to get a different JTAG. That's one of the things about the Sagers is they'll do pretty much anything.
And that's what about the educational one is
The
about.
educational one, I think that one's coming up. Yeah, here it is. Well, okay, so here's an example of the vendor-specific ones. Some of them can be cheap. They work well because they're integrated into the part, right? So the same manufacturer that made the micro is making the JTAG. So they tend to work very reliably. But they can be limited in scope, right? Just like I mentioned with the U-Link. It only works with UVision. And as you can see, the Pro, which was one of the ones I just passed around, is $1,300. Just the standard U-Link 2 now is about $420. So you have to kind of gauge it. And like even, and I should have run my pick hockey puck too. So you got the old pick chips, which, I don't know, is anybody still using pick chips for their robots anymore?
I have a friend who is using a pick chip to measure the timing for a 1957 car. And he's trying to deal with EMCs, so yeah, so the pick chips, there's people using them.
The last time I used a pick in a design, it was all 5-volt logic.
Yeah.
And I think picks still have, for an 8-bit micro at 5-volt I/O logic, it's still one of the most economical parts you can use. We use a ton of them in the elevator industry,
Yeah.
mostly for like communications. Like, for instance, a hall button in the hallway. When you push that button, that may be activating an input on a pick chip.
Huh.
And then it's sending that information over CAN bus back to the controller. So, and then here's the Sager ones, some of the cheaper Sager ones. I think the education one's in here, maybe. No, I guess I didn't get that one, Doug, sorry.
Well, there's one there called the Sager Micro Control.
Yeah, the $61 ones from DigiKey, those work pretty well. I mean, some of the guys I work with have those, and they are, again, they use the Sager driver. So one of the drawbacks with using Sager is you have to install their driver. But they have a lot of utilities where you can do memory transfers without even using an IDE. So there's advantages to the J-Link.
I want to say there was a Sager Educational Mini that was done by Adafruit, and I want to say it was about that price.
Yeah, there's a bunch of them out there. In like, who was it? The company, the online electronics company, Spark. It wasn't Spark Fun, but it was the. They made a series of JTAGs. I can't recall the name of it now.
Okay, now looking at the one that's the circuit board, the $69 one, it's got a slew of cables. Would that cover most of your needs, or are you going to have to find some other cables that you have to buy?
You got to be careful. That's what I was kind of driving at earlier. Is once you pick a platform, then you know what kind of JTAG you would need. Or it's like, if I can get this JTAG cheap, then I'll find a hardware platform. But we're coming up on that part of the presentation
Okay.
too.
But the essentially the little link you're using for ST, I guess it's an ST Link 2, was like
Yeah.
$11.
Yeah,
I think I've even seen them for $5. So I think I've even seen them for $5. So,
Yeah, I mean, there's
Chinese knockoffs.
There's tons and tons of them out there, and as long as they use the ST Link driver, they seem to work just fine. And even on these Nucleo boards, they have a JTAG built into them. So you don't even need the extra hardware if you get one of their dev boards.
Okay,
We'll
that's
get there.
very.
We'll get there.
So are you gonna talk about using the Nucleo onboard JTAG interface?
Yeah.
Okay, cool.
Yeah, I'm gonna demo. We're gonna actually build a project with VisualGDB for this board, and I'm going to show you how easy it is to get a light to blink.
Okay.
Okay.
Cool.
But we're not there yet. You keep
It
getting
took,
ahead of me.
it
Doug.
took you 2 years, 2 weeks to do this now?
Ouch. Okay, so as you can see, there's a lot of range in JTAG. So you just have to be careful about what your target is and what your development environment is. And one of the things you'll see time and time again is OpenOCD. And it's not necessarily a JTAG as much as an open source interface, like an open source driver for JTAGs. So a lot of the IDEs, and you'll see that that's when we get into Visual Studios, that OpenOCD is the driver that we'll end up using to talk with the JTAG. So that's one of the things that you might want to look for in support, both on the JTAG side and also from an IDE. Does it support OpenOCD? If it does, then those two elements are going to be compatible. Okay, and that's what I'm saying here is it's got a wide range of support. And it's also a native Linux platform is where it started. So it works really well with GDB, which is of course Linux native as well.
How about, any of this work on Windows platforms?
No, not as far as the JTAG goes, no.
Okay, so it's a Linux only for OpenOCD.
No, there is a Windows OpenOCD driver, yes, if
Okay,
that's what you were asking.
okay.
But no, GDB, I think might be a Windows version of GDB, but I'm not sure why you'd want to use it.
Yeah. How about on a Pi?
Yeah.
So a Pi,
We'll use, actually on a Raspberry Pi, you got to remember, OpenOCD is the driver to physically talk to this JTAG. So on Linux or on a Raspberry Pi, we don't have a JTAG, we don't have a JTAG port, right? Like we don't have those JTAG pins to tie into. So we're going to use the same platform, and that's part of what I'm trying to demonstrate is how flexible you can get with the platform. It doesn't necessarily have to have a physical interface. It can have basically just a SSH socket, but there are significant differences of the data that you can pull, right? Because you're not going to get the hardware registers off the Raspberry Pi. But in the same sense, you don't really need to, do you? I mean, that's all done by Linux and the Linux kernel. So unless I'm applying some overlay or need some unique pin configuration, I don't need to
okay, no,
worry about
Scott, what I
that
was trying to say, can I use a setup on a Raspberry Pi to use these Linux tools to do my debugging? Otherwise, I don't want to debug. I don't want
a Raspberry Pi already.
Yeah, I don't want
GDB
to.
is normally in it.
Okay, I want to debug an ST chip, and I have an ST link. Can I use to do my debugging computer, and can it be a Raspberry Pi? Would I be okay with that?
I don't know. That's a good question. I hadn't tried that combo. So
Okay,
I don't
all
know.
right, okay. They're getting pretty fast with the little files.
OpenOCD and GDB are going to be native to Linux, but VisualGDB and Visual Studios doesn't run on Linux. So, as far as I know, there's not a Visual Studios
Okay,
platform.
I didn't know
or
that.
distro that runs on Linux.
Okay,
If there is, someone let me know. Okay, so since it's kind of open source and was also a Linux native, in some IDEs, using the OCD driver can be flaky. And normally the ones that I'm familiar with, like for instance, UVision doesn't support OpenOCD. And that's one thing that makes the U-links that, incompatible with other IDEs, right, is the driver that's talking to it. So let's talk now that, first of all, does anybody have any questions on JTAGs itself, the hardware side? Because we're going to kind of move on now and talk about what the JTAG can do for us. Okay, we good with that?
yeah, I think so.
Okay, so JTAGs give us all these tools that we can play with and help us debug our code. Like for instance, we can set breakpoints, right? We can set memory watches so we can look at memory, like I do a lot of memory overlays when I'm adjusting parameters, right? I don't reference a single parameter, I just take all my parameters as a block and I overlay them in memory. So a lot of times it's important to watch the memory changes. Okay, what element in memory actually changed, right? So, and then one of the newer tools that VisualGDB just came out with a couple of years ago is a live watch. So instead of, like for instance, having to set a breakpoint and look at, okay, what's this variable at now, right? You can actually set it up, and while your program's running, you can see it change in your debug window. And I'll demo that here, which is one of the things that I use quite a bit. The limitation I found that is you have to have a global variable to do it. So like if you're trying to monitor a local variable in a function, I just kind of temporarily assign a global variable to it if I want to watch it. And of course, the debug port, in some JTAGs, there's what they call a TDM port. And I'm not sure what the acronym stands for, but it's basically like a serial debug port through your JTAG. So you don't have to dedicate a UART off your micro to have like a JTAG, or not a JTAG, but a debug terminal, right? Where I can just interact by, like PuTTY or TerraTerm with. I find that to be very helpful in developing, and especially like when you get a bunch of variables that you want to, because everybody's done it. It's like, well, I'm just going to hard code this number, and then it's like, oh, I need to tweak that. So then you got to change it and recompile and reload, and so if you just have a variable that you can play with, it makes life a lot simpler. So I normally have a debug port dedicated off of the micro. I tend to stay away from the debug ports that you can get through the JTAG because it's not portable. Like at work, I deal with a lot of different families of parts. So we're looking for solutions that we can migrate from one part to another. But in this environment here, and if you're just playing around with it, and you have a constrained limited chip, then you can certainly leverage it. It's not hard. A lot of times there's driver files in the program. Now, something I'll also caution you, this is not necessarily just for a C language, right? We haven't even talked about what kind of development language that you're working in right now. Now, all of the demos I'm going to give are all written in C and C++ because that's my native language. But there's no reason why the same approach wouldn't work on Python code or even like an Arduino. And when we do the demo, you'll see that there's an Arduino project framework that you can go ahead and load, just like I'm going to load the one for this board here. All right, so this is the same slide. Oh, okay. Sorry, I duplicated that slide. So here's the instructions that Paul posted on the web. You can download VisualGDB and you get a 30-day license. And so just to show you, this is their website. And just to give you a little bit more overview of VisualGDB, there's cross-platform development, right? But the IDE is always the same. So you always have the same functionality that you get with Visual Studios. So you can do embedded code, and you can even, it has a trace function or a scope function where you can actually look at a pin, or like this would be an analog pin here. You can watch digital pins graphically, just like this. And like you see here, this is one of the live window variables that I think is a really cool feature. Yes, sir?
You're not sharing your,
Oh, I'm not?
your window?
Huh.
You're still sharing your presentation?
Well, now, I'll have to fix that.
There you go. That's easier.
There we go. Okay. All right, so let's step back here a second then. Of course, you got the cross-platform capabilities like I was talking about. And again, you've got all of the it's a common interface, right? So you don't have to relearn it every time you start with a different chip, or you decide, I'm going to upgrade, or I'm going to go from a W2 Pi to a Raspberry 3. Well, this gives you the same set of tools, and that's not a real good example, but like you'll see that from the Pi here to the ST Micro, we have pizza being delivered for those aren't here. So, and again, we've got the debugger, and we'll walk through all of this. I just wanted to kind of show you their website and the embedded tools, and you can see all the different platforms that are natively supported on this. You can also take earlier projects, like if you get example projects for a Kyle example, and you want to reuse it, well, you can import that project, and it'll actually build the project and all of the settings for you. And basically, it'll use that, the project footprint, if you will, so that all the included files and all that. Sometimes you have to play around with the include paths, especially like the system level include paths. Sometimes it doesn't get right, but and like I said, you can do Arduino. There's been a lot of ESP stuff done, right? They've got some really nice tools. And this will also has an interface for Raspberry Pi where you can actually compile locally on the development machine and then send the exe over. So it really speeds up, especially like with a big program, it'll really speed up compilation time. And also download time, because what'll happen is it'll update whatever files that have changed on your machine that you're using to develop with. It'll send those over to like the Pi, and then it'll tell GDB to compile, or not GDB to compile it, but the Linux tools to compile it locally on the Pi. So you can kind of circumvent all of that activity, compile it locally, and then send it over, which is a pretty nice feature. And like on Belch, which is a pretty good sized project, it did help some. Sometimes it'll lock up transferring it, so it's not, it's not 100%, but, and then of course, like I said, you got Linux development here, and again, we're going to use an SSH socket to talk to the and see here, it's got a Raspberry Pi running Ubuntu 19. And Carl's comment, the Linux version does everything that most of us need it to, because it includes a Raspberry Pi and BeagleBone support. And that's the cross compilation I was talking about. So you could, with the embedded version, you could potentially finagle it into doing a Raspberry Pi project, but you would always have to compile it on target. You couldn't do cross compile.
So you run Linux on your, so where do you run this is a plug-in to your development box?
Yeah, it's a plug-in for Visual Studio.
And your development box is Linux?
No,
Windows?
no, I use, Windows.
So how does the Linux plug-in work on your Windows box?
Well, there's a binary as far as the cross compilation, the local compile.
Well, just like this $109 column, that one. If that's the one you're running on Windows, how does that run on Windows if it's made for Linux?
It's not made for Linux.
Oh, it's not?
This is just providing support for Linux or Raspberry Pi / Linux development.
Okay.
So this is what gives you kind of the cross compilation and the local compilation tools. But ultimately what this thing does is it uses the CMake framework. So you can basically, you could force feed it whatever platform you wanted to.
Okay.
And it would just basically put the framework of like a CMake file in your development environment. And most compilers, or most IDEs can support CMake, right? It's just a script of telling it what to do, right? It's kind of arcane to look at and try to modify, but Visual Studio or VisualGDB does a pretty good job of building that for you. And really for $109 for a full development environment, because Visual Studios is free now, right?
Right.
You can use either the community or code or
Yes,
the
code.
community version.
Okay.
And a lot of people are using code because it's really nice for online stuff, right?
Okay, so these columns, the column headers then refer to,
This is
No.
just what they call that package,
okay,
right? So this is their Linux package, which is the same as their embedded package, but it includes these built-in tools.
right, okay.
And for another $10, they're well worth it. And so basically, you buy this online, you can download the example, it'll run for 30 days. And then whenever you're ready to purchase it, you can just go online and buy it, give them a credit card number, and then they'll email you a key. And then you just plug that key into the IDE.
Right.
Any more questions? I was going to transition here to the demo, so maybe this would be a good time to break for the pizza, since it's here.
Well, it's hot.
Do I have anybody to object to that?
No, that sounds good. So we'll break for pizza
Okay.
and come back with the demos. All right.
And for those people. I'm gonna try that.
And welcome back, everybody. We've had our lunch break here at Makerspace Central in Dallas. And now it's time for the live demo fraction of this presentation. Take it away, Scott.
All right, so like I said, this is, here, let me just close this real quick and I'll start. So here's Visual Studios, and I'm just gonna start it normally. And of course, are we up there?
Well, we can see it, but it's not, the camera's focused on your demo.
That's fine. I'm gonna show the LEDs here.
Okay, so for those online or in the video, unfortunately you won't see Visual Studio at the same time because we don't have a camera on it.
That's fine.
Unless you wanted to join the meeting and share your screen.
Well, as soon as I get done with this, I'm gonna have to use my Wi-Fi to hook in over here. I mean, I can do it for
The other thing
this,
is,
but
I could get up there and spin the laptop around and move the camera. Does it make sense to show them both at the same time?
no.
Okay.
Come on. You gotta love Windows. All right. I guess I should have stayed with the original one I had open.
Sorry.
All right, so basically, like I said, I just opened up Visual Studios, and once you have installed, and basically the installation of VisualGDB happens. So you install Visual Studios, and then once you run the installer for VisualGDB, it'll go out and find your instance of Visual Studios, and it will record it, or basically it'll integrate with it. So now when I go to create a new project, I have embedded wizard, and if I go to on my platform, wait a minute, now this didn't open right. Okay, so normally I would have Normally you'd have, let's try this one more time. So here I should have my Raspberry Pi project like we saw earlier. I'm not sure why that's not coming up over here. Let me do this. Usually, so let me open up 2019, which usually works better. And as you can see, I was playing around with Python. So anyway, let's just create our embedded project. Normally we would have like a Raspberry Pi option there too. And so basically you just name the project, you give it a location, and you say create, okay? So this is where you start setting up project options. And we're just gonna stick with most of the defaults here, which is MS Build. You can do the advanced CMake, and then that uses the CMake stuff, like I was talking about. Or if you're just doing really hardcore Linux, you can do GNU Make. But, and here's where you can import, you can create a project from a custom template. So you can save templates and whatnot, but we're just gonna go with some of the original defaults. So this board I've got here is the Nucleo version of ST's platform boards. And I really like this family of dev boards. They're really cheap. Like this one I think is like 25 bucks. And the CPU's got more horsepower on it than a robot will ever need. I think it runs at like 500 megahertz and has all kinds of pins. I mean, it's got like 6 UARTs and 8 I2Cs. But you can get other boards, like smaller ones, they're smaller chips, like they're F-series chips. And it's just like Arduino, where there's capes that you can put on it, right? So here we're gonna
It's okay.
define, and this is a 723 chip. And as you can see, it's got a gig of, or a meg of ROM size, so there's plenty, 128K of RAM. And it also has a native or hardware floating point, which can be, especially when you're doing odometry and doing math, a lot of heavier math, a software floating point support can really tax a CPU, right? Because it's doing the same, it's doing division in multiple iterations, whereas if it had hardware floating point, it's a single iteration. So that's the other thing I like about this. These are the H-series chips, the ST32H, and there's 4s and 700s, and there's all kinds of different options. But once you get to the H7s, which is an M4 Cortex core, then you have hardware floating point. And so I'm also going to go ahead and enable floating point support for printf. And then it went through and it checked to make sure it could compile. And so now it's given us options of just basic programs we can start with. And I'm going to just pick one that it's going to give us an RTOS. The FreeRTOS is part of the package here, so I can just tell it to include FreeRTOS, and then I'll have things like threading, mutexes, mailboxes, and whatnot. And the other thing, like I'll show you, is we'll already get, like you see down here, is the low-level drivers aren't enabled. But what we'll get is we'll get the default HAL drivers, and I'll show you that. So basically, this particular board, I got to change the LED numbers. I got my cheat sheet. Okay, so what I'm doing here is I'm telling it, okay, my LEDs are on port B, pins 0 and 14. And what this is going to do is it's going to create an example for us with a couple of threads that basically kind of give you a show of how threads would talk back and forth. or actually not really talk back and forth, they would interrupt one another. One thread pauses the other. So the last thing we have to specify is our debug method, and this is why we're all here, right? The JTAG that we were talking about. So here, I'm going to select my ST link, and notice it's OpenOCD with ST4. And again, OpenOCD is open source, so there's been a branch that's been specifically for ST. All right, and then we're just going to leave the rest of this stuff at the defaults. And I won't really go into the difference between the JTAG and the SWD. It really has to do with the hardware pinning. We're going to be using SWD, and that's fairly common approach. Okay, so now I'm going to finish. And here's our project. Watch it not load right. Okay, so now we have our project, and here's my source. It's already organized the project for me. I have source files here. This is the main file here.
And this is all in your development box, right, at the moment?
Yep, this is all Windows centric. And you can see here it created the HAL init code. It created a couple of threads. Our system tick handler, which is one of the requirements for like an OS. I mean, if you're doing bare metal or RTOS in C on an ARM platform, you're going to have this system tick handler somewhere. And so here's our first thread. We're going to turn on one of our LEDs, and then we're going to wait 2 seconds. We're going to turn off the LED, and we're going to suspend the other thread. And then we're going to wait 2 more seconds, and we're going to resume the other thread. Okay? And then this is the thread that we're starting and stopping. And all it does is it loops every 200 milliseconds and toggles the other LED. So as you can see here now, we have no LED blinkage at all. And that's,
I'll take care of this. Are you going to do that one? Yeah. That's even better.
okay. So now I'll run, basically all I have to do is click the VisualGDB debugger here. And it
Wait a
goes
minute,
through
whoa,
this
whoa,
thing.
whoa, hold on. All I got is Carl's butt.
Oh. Yeah, it's a little,
Okay, so,
Okay. And now you should see the LEDs blinking.
okay,
The red one will blink several times, and then it'll stop, and then the green one should blink. And so that happens every 2 seconds. So, boom, that didn't, honestly, honey, it didn't take me 2 weeks to do that. So that's how easy it can be to blink an LED. Okay, but, you know, blinking an LED is not really that useful, right? I mean, it's a beginning. So let's look at a little bit about what how that happened real quick. So basically, I can go through here and adjust. Like if I right click here on my project, I can go into VisualGDB properties, and this is where all those things I set up before when we were creating this project, this is where I can go in and I can change them. Like here's my debug settings. This is the settings that we set. So I can go in here and change them. If I want to use the same code for a different target, then I can just retarget it here as well. My build settings, so my include directories, like if I'm going to start including any libraries, which is much more important on the PI side, unless you come across like a sensor or something that may have a lib file for that platform. But this is where you would go and change the embedded part, the stuff that you're not familiar with. Like if you're familiar with using Visual Studios to develop a console app for Windows, this is stuff that you don't have to mess with, right? You don't need to worry about the include files or the include directories, where to search for library files, what the names are, that sort of thing. And then if I wanted to go back, again, this is all stuff that I had configured when we built the project originally. So, like I said, this is where you go and change anything. So, again, we can come down here, like a traditional breakpoint. And you notice that screen right there, that was it loading the file through the JTAG. All right, so here we've hit our breakpoint. And of course, we can look at what's going on here. There's really not a lot to work with here, right? So let's give it a little bit more to play with. For instance, let's just say that we're going to have a counter, right? And then, of course, showing the ability of Visual Studios, you know, boom, they're, you know, kind of auto-fill this in if we want to. Same as you would any other time, right? And I think anybody that's worked with an environment that has a breakpoint, we could say, all right, well, if counter's greater than 10, then let's just reset counter, right? And I don't know about y'all, but I've done this plenty of times and set a breakpoint there because I was only really interested in if counter got to be more than 10. Like if it's a buffer or something, you know, the situations where you would need to do that can be endless, really. So this would be one way, and if you ran it now, I'm going to hit this breakpoint when counter is greater than 10. But, you know, maybe there's a better way to do that.
Scott, can I ask you a question?
Yeah, because we're going to wait 20 seconds for this to happen, so.
Oh, okay.
Okay.
I got 19, okay, so 18. So when you set the breakpoint, do I understand correctly that the fact of that breakpoint attached to that line of code is then transmitted down onto the target device, so it catches it there? So is that the way that it, because it's a serial port, so it takes time to transfer things. So is this the way that it's able to stop exactly at a specific line of code without having to worry about the delays of the transfer?
No, not really, because if you're hitting a breakpoint, you're just going to stop.
It stops,
Right.
it just
So
stops.
it doesn't matter, it's not really time critical to say, well, it took me 100 milliseconds to stop,
Right.
right? It knows when it gets to that line of code, it's going to stop.
But the stop is there in the chip, not in the development environment.
No, the stop is actually written into the software.
Oh,
Basically, it says, okay, at this address, execute a breakpoint. Now, there's microcode, like an assembly language instruction, to tell the micro, you've hit a breakpoint. And that's what's in the instruction set. So that's where the software and the hardware kind of tie together, is the physical way you're stopping the execution of the program is hardware on the chip. The way you're telling it to stop is via software.
perfect.
That makes sense to you?
Yes.
Okay, and as you can see, we're never hitting this breakpoint. Anybody tell me why?
Because you never implemented the counter?
Bingo. All right, so now let's say we'll go down here, and boom, there's our IntelliSense again, counter, and we're just going to increment that, and we'll rerun it. And by the way, too, Carl, it's when you're loading kind of back to your question, when you load it, that's all hardware centric. So that's the JTAG interfacing with the JTAG hardware registers on the chip, saying write memory here,
Pumping
write
bits
this.
into memory.
Right, basically it's what they call an ICP, in-circuit programmable.
Yeah.
So basically it's just using that hardware, and that's actually a hardware module in the chip. That's actually part of the ARM spec. So any chip that calls itself an ARM has to have that functionality. That's part of the technology that ARM provides. So then you're just telling it, you're just using those registers to write out to memory. Right? What it writes into memory, it may not only be the application that we just compiled, but also the instruction to say you need to stop execution, which is a software instruction that just gets inserted in that line. Like right here, this breakpoint that we just hit.
Yeah.
Right? I was executing that section of code, and the next instruction was basically you hit a breakpoint, so stop. And then the hardware in the microcontroller knows, okay, I need to halt. Now, part of the problem in robotics, or really any time you're using that, is time stops. So if you're sitting there wiggling a motor drive PWM pin, well, if it's low, then the motor's going to stop. If it happens to be high when you stop time, it's going to be high. And so while you're at this breakpoint, your motor's screaming in your ear, or if you're not careful, it may be running across the counter.
Or something that should have a duty cycle is stuck high and about to burn out.
Right. Or you could burn something up. Exactly.
Okay.
Okay, so here, counter is more than 10, but here, and see, notice it came out by default, it's a hex number. You can tell that by the 0x here, right? That indicates that it's hex. So if I right click on this, I can do a couple of things. Like I can go ahead and edit it here if I want to, and change the value and tell the code to continue executing. Here I'm just going to make it here. Now, anybody got an idea why it's 20? This should have hit if it was greater than 10, right? Well, down here, we're incrementing it every 200 milliseconds, but we're only testing it here, right, every 4 seconds, because you've got 2 4-second delays. Okay, so that doesn't, say we were interested in the 11th count there for whatever reason. Now it's like, well, how am I going to,
When you get there.
what? So I can also, let's stop this. So what we're going to do is we're going to eliminate this code altogether. And I'm going to set a breakpoint right here. And I'm going to make it a conditional breakpoint. So I'm going to use this expression, which gets this little cut off there. So I'm using this conditional expression, and I'm going to say counter is greater than 10. Okay? And then we're going to save that. And I can even add another condition here and say that the hit count is equal to 2. So in other words, the counter's been greater than 10 more than twice, or 2 times. But we're not going to save that. So basically, we just have a conditional expression that if it is true, counter equals 10, then I'm going to hit this breakpoint.
And the breakpoint logic, is that evaluated by the main microprocessor core or by something special in the JTAG module? Or does it matter?
You know, I think that falls under don't look a gift horse in the mouth.
Keep
To
that
be
in
honest
mind.
with you, I'm not really sure. I know it's functionality that was included in VisualGDB latest versions. So it's obviously coming through their plugin somewhere. Now, how they're
Oh, they're doing it.
I don't know. They can communicate back and forth with the JTAG anytime they want. So there's a lot of communications going back and forth.
Without interrupting program execution.
Right, and well, you're like getting Doug now because you're getting ahead of the
Sorry.
program. Okay. So now we've hit this breakpoint. Well, what's count? And counter's 20 again, right? So we only did this test. You're only testing the breakpoint whenever you come through here, right? So it's not a global kind of thing. But that kind of shows you one of the features of the breakpoints. Now I'm going to show you some other features that I haven't been able to get to work. And I'm about to the point of posting it on their support. Because one of the things, like here, we just said, okay, well, if this is true, stop here, stop execution. Well, we can do other things too. Like, for instance, you're supposed to be able to print out a message in the output window, which would be great, where you could just basically have like a printf message to say, oh, well, this breakpoint or this condition exists, right? It wouldn't necessarily be a breakpoint at that point. It would just be a point in your program where you're going to test, hey, does this condition exist or not? Whatever is in our conditional expression, which here is counters greater than 10. But I've yet to see this work. And you're supposed to, like here in the example, you're supposed to be able to, like a printf statement where you can print out the value of it. And from the documentation, it doesn't necessarily have to be the value of, for instance, counter here. Like if I had another variable called time, and I wanted to see what time was when counter was greater than 10, then I could have it printed out, is the idea. But either I'm doing this wrong or it doesn't work, because I haven't been able to get it to work. So if anybody does pick this up and play with it and gets it to work, let me know. Because that would be kind of interesting and neat feature, right? I mean, I've spent hours debugging programs and I've never used it. So would it have been useful to have that in my toolbox? I don't know. And a lot of this stuff, especially like conditional breakpoints, to me that's kind of not an upper tier, would be kind of the wrong way to say it. It's not functionality that's needed day in and day out, right? Normally when you're using a breakpoint, it's the fact that your program got to that point.
You don't know how.
Right, whether it got there or not, and now I can, and a lot of times you want time to freeze because you've got other things going on, so now I can really look at everything that's making decisions or, you know, all the conditions of my variables, you know, in stop time. I don't have to worry about, oh, well, it changed, especially like in this example where you got two threads running, right? So one thread's affecting what the other thread is doing. So it's not like I would recommend you go out and you look for a reason to use a conditional breakpoint, right? Normally, you know, it's just, I'm just giving an example, kind of like Mike, you know, why did you put it on a 2W? Well, because I had a presentation to give, you know.
Nice tool.
But it is nice to have tools like that, right? I mean, it's almost as nice sometimes as IntelliSense. So the other thing that I like, that I find very useful, is say we're just gonna continue execution here, and our little lights are blinking, right? So one of the things we can do is we can go and look at live watches. In other words, this is kind of what I was saying before. So I'm gonna add our illustrious counter variable into here. And And now you can sit there in real time and watch an increment. You know, what is it now? So you can see it, and it comes up in red when it's changes. And you can look at all globals here as well, like a lot of your stack information, your tip counter, like the, there it is. Like your X tip count, this is what your OS is using. And then down here, it shows you it's updating 9 times per second. So a little more than every 100 milliseconds, it's updating these variables. And that number will increase, or I'm sorry, decrease, depending on how many variables you have in the logs, right? Because it has to query each one of them. But it's doing all of this over the JTAG interface.
And it's doing it without slowing down the program operation?
The program is running in real time, yes.
Real time. So, and then whether you have JTAG enabled or disabled, does the program run at the same cycles? So it's a
Because it's ultimately, the JTAG is talking to onboard hardware. It's not...
onboard hardware, and it's just reading values,
Right.
you know,
Now, there may be some minor
overhead some.
overhead to it,
Yeah.
but not that you can tell.
And when you've run this like on belch or burp or, it hasn't, has it affected the kind of real-time loop behavior that you've noticed?
Interesting you brought that up, because why don't we look at the project that usually runs on this guy,
Yeah.
which is obviously a much bigger program than this. So let's stop this. Another thing I want to bring out here too that I found that I like about this development approach is a lot of IDEs, development and debug are two different screens. Like if you ever use an Eclipse-based IDE, right, you drop out of editor and you go into debug, right? It's a whole different environment. Whereas here, it's more or less seamless, right? I mean, some of the windows, some of the supporting windows around the code changes, but it's not like you're dropping into a whole nother environment. And a lot of times you can change, like another thing I like is you can change the program count. Like if you wanted to go through an init process again, it's like, well, you just move the program counter up. Here, I'll show you. Of course, this is not going to be a very good example, but like if I put a breakpoint right there, all right, so now I can grab this little yellow line here, and I can
Drag it.
move it. Now, notice it wouldn't let me drag it outside this function,
Ah.
because, and that's part of like the threading, right? And that's also, this is a declaration, so there's not a line of code associated with that. But like if I wanted to go back up and have an increment counter again, which now is 1, and then if I hit F10, it's probably going to be 2, right? But I know I hadn't gone through that loop one more time, right? So that's also something that I find very useful, where you can kind of go back and get another shot at it instead of just restarting it.
But do you find it sometimes confusing as well? Because you're only changing the program counter, right? Or it's not changing the state of memory.
Well, but no, I can't.
You can't.
Like for instance, I can move this back up here, and I can go in and I can edit.
You can edit the value.
I can go in and edit the value.
Okay. It's just more to keep in mind, but you can do it.
Right. And I can make this, let's make it a 12. And then if I step, all right, this is 13 now. Now, what you have to be careful of is there something dependent on that? I mean, I think what you're driving at is you can back yourself in a corner manipulating things like that, because it's like, well, oh, this other variable needs to be, like this flag is set, like especially like on a init routine, right? You may have a flag set that says, hey, I've been here before. So you got to be careful, and you can shoot yourself in the foot, but all you got to do is stop it and reload, and normally you're right back to where you started. Okay, so to get back to Carl's other comment is how does it affect a bigger program? Let's just open up a bigger program. And lo and behold, I have that program right here. And as you can see, there's a bunch of files in here. This is the code that runs on this robot, which I call YAR, which my wife actually named. I showed it to her. She goes, oh, great, another robot.
Yet another robot.
So I called it YAR for yet another robot. And of course, so you have a lot of stuff going on here, right? So let's run this. Okay, I went through this before, and you were happy last time. Yeah, see, it did this to me last time, and it's going to say that it failed, but it ended up loading the program anyway. So I'm not sure what's going on with that. That was part of the debugging. I was going to make sure everything ran on this computer this morning, but then I found out that I had 2 less hours, because I thought this started at noon.
Mike,
So,
would you like your track line?
okay, so, like I said, I don't know why it's doing that, to be honest with you. All right, so we have our live watch here, and let's look at our globals, which is what we were looking at before, right? When we had, I think it was 9 times a second. And see here, it's a bigger program, and we're doing it 10 times a second. So there is a little bit of decay, but not a lot. And as you can see, like all this behavior pointer, all of this stuff right here, this is all part of the program, button port. So all of these, like for instance, I'm going to mess you up now. All right, so basically now now that the program's running, right? And if I hit the button, it's going to try to, I think this is out and back. But what I wanted to show you is some of the updates here, like my encoder direction. We can look at the encoder counts here. And like I said, you'll see those. You should see those. Okay, well, maybe not. But this gives you an idea, too, of the speed. And see, this is my behavior mechanisms. And we're still at, 100 and something times a second. Of course, it says 10 here, so.
I guess it's average and peak maybe, right?
Yeah. And like here, this is a state variable that shows, okay, we're doing an action here. And then every time this goes to 0, that means that action was completed. So again, we still have plenty of performance here to look at the data. So that's really, I tell you what, let me get connected to because unless anybody's got any more questions about the embedded side, I'll show you real quick how it works on the Pi side, and then I'll be done. Okay? So no questions? Really?
She's not coming already. See, it was so well prepared and presented. You answered the questions before we could answer them. Ask them.
Yeah, I was
You nailed it.
winging it. All right, see, so here I'll connect to, what I do on my Raspberry Pis is I set up a access point. So the Raspberry Pi is the access point. And that way I don't have to worry about the IP or anything. I don't have to worry about a local network other than, getting a channel to run it on. And it also, this connection also has SSH enabled because by default on most Linux platforms, you can't do, have root access over SSH. Okay, and guess what? Just conveniently, I already have built this program program open. You'll see a lot of the same files because I've decided I'm going to call it the FART platform, for Fast Autonomous Robot Technology Platform, because I use a lot of the same stuff like my action stack, my behavior stack, a lot of the resources like a GPS, AHARs, an I/O module so that you can programmatically access I/O. So I have a lot of commonality. It doesn't matter whether it's embedded or on a Raspberry Pi, because it's written in C, I can pretty much just direct it wherever I want to. So I have a lot of the same code, and that's one thing that makes building them more efficient is I'm not having to reinvent the wheel every time I put together another platform, right? I just kind of port what I have into that hardware or tune it for those motors or whatever the case is, right? So here, you would go through and you have to set up a host or an SSH connection. I'm not sure why this one doesn't have one, but we can set up a new host. So the host name is root at
Oh. Whoa.
Somebody didn't pay a bill.
No.
Put on the slot.
Yeah.
Wow, our notebooks are running.
Yeah.
If only the internet connection was alive.
well, and this is running off of
Oh, you're right.
wall power, so
Yeah, so,
that's running off a battery, so it doesn't.
Fun.
Oh, I'm running, my phone's running off.
Your phone is,
Power.
yeah. But they ain't no internet.
So anyway,
I could get them.
We got power.
Break.
well, I mean, I'm wrapping up anyway, so this is really the method that you would use. Come on now.
That's one way to get us out.
Well, we have this room for another hour. A warning rate.
So they should be doing construction.
Okay, and then I think that's the right password. Okay, well, obviously it's not.
Thank goodness for the backup on battery.
Yeah, well, I was thinking about that with the battery, and I don't use this very often, the battery, but we've been here present,
Yeah.
so the battery charged up.
It's in, yeah. Scouts on.
Yeah.
So the battery is
Doug, I'm not seeing your presentation.
doesn't do that good, so.
Mhm.
Okay, so another thing I like about this platform with VisualGDB is once I've set up this connection,
No, I'm not, this isn't on the meeting.
then I can test it, make sure that, and basically this is just a ping. The other thing that's really nice is they have this nice console. And they have like a regular console, then they have what they call a smart terminal, which I like to use because you can, it's like, almost like File Explorer. This is the file directory on the Raspberry Pi right now. So I have access, I can transfer files, I can do SCP transfers, I can transfer a whole directory. Like if I have files on my computer that I want to load on there or vice versa, and I can use these tools to both load and download. The other nice thing is you can edit right here as well. Come on.
And this is a part of
This is a part of VisualGDB.
VisualGDB, okay.
See, now it doesn't want to work. Yeah, I don't know, connection dropped off. Well, maybe through the power. I just thought it was connected. Okay. So yeah, we can, like if I go into my home directory, I can go in here, I can edit. Like I just double clicked on it, I can go through here and edit it. You know, this is the illustrious config file, or the, oh, this is from, who was it, Ted put together the run headless. This is from his. So anyway, it's really nice to not have to drop out of the IDE or type command line, you know, ls/dev, whatever, you know, or nano, this, that, or the other. You can just do it right here. And you can save it, like once you modify it, you can save it and it'll actually write it back. Or if you don't save it, it'll just hold this in memory on the terminal, which is kind of nice too, because you can like put notes in there and if you're trying to debug something. So I like that feature about this terminal. And as you can see, it'll just open up multiple ones, so I can open up multiple files too if I want to, and just keep them open and kind of jump between them and figure out what's going on. So I think that's really nice too. Okay, so now we have our connection. So we're done with that. So now all I got to do is hit run, and you'll see it over here, and it should compile, hopefully. Yeah, and see now it's actually running. You can see the LED here blinking on there, and
It's like Mike can hear us.
like I said, we can go into the windows and where's our
We had a power loss here, guys, so I'm going to try and get the right camera going.
Okay.
So it's not me.
maybe live traces don't work on Linux. I don't see the
That's
option.
right, like, can't hear us, I guess.
Okay. Oops.
Video looks active.
There we
No, I
go.
can't connect to Wi-Fi.
Yeah, I can see it.
How's
Wi-Fi
that?
still down?
Yeah.
It probably will be
Okay.
for a while.
Yeah.
So
We'll be a bit surprised. I'm not sure.
we are out of Wi-Fi, so we're making do by battery power or
Or it's phone,
phone connection.
so yes.
Who was it, Doug, or someone? I guess the live variables don't work on through the SSH. I don't see how you, because normally one of these windows that you can open up here under Debug is where you open up the the live watch. But I don't see that option enabled here. Unless it's under here. And see, it says UI debugging is either disabled or not supported. So, unfortunately, it didn't work out the way I wanted it to, but, all right, any questions? If I have any comments, any rude comments, any nice comments?
Well, so can you revisit what are we showing here? Because right now is JTAG involved with the,
Okay, right. So, no, right now, we don't have JTAG involved. We are just running over SSH, right? But there are a lot of the same things can occur. Like here, I'll go ahead and set a breakpoint here on the entry, and we can still look at, we can still set conditional breakpoints if we want to. Same as we did with the embedded stuff. We can still look at any kind of variables that we want to look at.
so if I understand then, the value of this is that with this one plugin, VisualGDB, you can either use the JTAG debugging as an embedded mode, or you can use a Wi-Fi shell into Raspberry Pi and just run like debug it like you normally would, but it's all still from one kind of interface.
Right. Notice, I mean, we've never left Visual Studios here,
Yeah.
and everything looks the same, right?
Yeah.
So you don't know, other than the nuances that we've just identified, where the log trace doesn't work. But we still have conditional breakpoints. I can still, set locals, because like locals will come up here automatically. I can set watches on different values. Now, there is a context here, like you notice this is not in context at this particular breakpoint. So like these are most likely not global
Because of the
variables
red
or
X.
objects.
The red X means they're not in context?
Right. Or they're not available. They're not available for some reason. Not being out of scope may be one of the reasons.
Okay.
And I haven't opened this project up in a while, so it also may be that some of these don't exist in this project anymore. But they're still on the watch list because they were added there at one point in time.
So does like Visual Studio have built-in debuggers, or do you need to use a library like this?
It has a built-in debugger for Windows apps, yes,
I see.
but not a JTAG interface. That's where VisualGDB has its value, is creating that ability. Now, yes, we could probably configure Visual Studios with a SSH socket to do exactly what I'm doing here with the Raspberry Pi, but not for a platform like this,
Not for embedded.
not for an embedded.
So this is one ring to rule them all. Is this the one you use by default?
Yes, I use this platform at work. I've introduced some of my coworkers to it, and they all, of course, several of them are using Green Hills Integrity, which is one of the worst IDEs I've ever had to work in. It's just horrible from a user perspective. It's a very powerful program. I mean, it's aircraft or avionics certified compiler, in RTOS. And they use it for our elevator systems. But basically, the control systems are written on Green Hills. So it's very powerful, but it's a pain in the ass to use.
Okay, so this is Visual Studio with the add-in VisualGDB.
Right. And getting back to like Green Hills, I've actually set up, and that's what I was mentioning about the CMake files. So I've actually set up Visual Studios to be my editor and IDE for Green Hills, and then I shell out to Green Hills Debugger. So it's like I was talking about before, like with Eclipse based, where you have a separate debugging environment versus an editing environment. And then because you have the development, which is the editing, and then you have the compilation and the linking, and then you have debugging, right? So those are three separate blocks that all have to tie together. And typically, Visual Studios will only do the editing on cross-platform. So Visual Studios provides the compilation interface, the compilation exe, the binary that's actually running for that target. And then they also provide the debug facilities, strictly inside Visual Studios.
Yeah.
And this is 2019, you said?
This is 19, VisualGDB will work with anything other past like 2007.
Yeah, but you said you like 2019 as being the most stable?
I've used both of them in this. I don't really see a stability change
Okay.
from my perspective.
So would it be better, newer is better, or is?
Well, 22 and above supports the Copilot from Microsoft.
Yeah, okay.
So that's one of the advantages you have with the later version Visual Studios, is being able to integrate Copilot in it. And that's something I haven't even played with. Some of my coworkers have, and from a conceptual perspective, how would I write a driver for this, or it'll get you started, but there's still a lot of work to do on the back end, is what they've been telling me.
Well, I've been trying to I've been setting up a environment for my Raspberry Pi 5, which I have multiple Picos plugged in, and I've been using Arduino on the Pi 5 and using VNC to connect to the Arduino platform, and then I can configure and test the micros without having to unplug them and plug them into a Windows computer. I assume if I ran Visual Studio on the Pi 5, I could use this and do my debugging like that. Or is there any way to use it like Visual Studio on your PC and have like a two-level, like go to the Pi and then go to the micro connected to the Pi and debug on the window?
Well,
It's
you're
just-
always going to be limited to one debug interface, right? Like here for the Pi, this is an SSH socket.
Right.
So whatever access the SSH socket on the Pi has, then you would have the same access. But if you don't have access from that socket on the Pi, then the answer would be no. Because whether you're doing it over JTAG or over SSH, you still only have one debug method you can select.
Yeah,
So you can't intermingle debug methods unless one method is a subset of the first method.
Well, I was thinking that I wouldn't be debugging the Pi, I'd be trying to debug the Pico, which is connected to the Pi,
But, well,
From the
how is it
PC.
connected to the Pi though?
the USB port.
Okay, so it's, what, a
so
VCP
the
to
way-
the Pi? Or?
No, it's just a serial interface to the Pi.
So it's a visual COM
Or
port.
basically, like in Arduino, when you change the code and then reload it, it does that strange background.
Yeah, I don't, never worked with Arduino.
the
so I
way,
don't-
the way I found that works really well for me for doing that, I use the Windows subsystem for Linux. And I basically pop open a terminal there, and I SSH-Y over to my Raspberry Pi, and I just run all the development environment off of the Pi 5 itself.
Yeah, that's what I was doing, but I was using VNC and desktop. But yeah, so.
Yeah, I find that
It's similar.
the SSH through the works much better than the VNC. VNC gets kind of flaky in what it allows and doesn't allow.
And VCP in that situation would be running over an SSH socket. Anyway.
Right, to the Pi, right.
And VCP is just giving you the extra tools
Yeah.
on top of the socket.
I was just going way outside the box there. Yeah. Can I do this? I'll be done. Okay.
Well, you can always ask, can it do this?
Yeah.
The second question you should ask is, should it?
Because I want it to. Yeah. Okay.
So does that mean you're gonna run ROS on an 8088 pretty soon?
No, on a peak, on a pit.
On a PIC, okay, even better.
Yeah.
Good.
Well, wouldn't that be more minimum than the Pico?
Yeah.
And in putting this presentation together, I at one point I toyed with putting together like a MicroPython presentation part of it, because I know a lot of you guys use Python, and Python has its place, right? I mean, there's for kind of prototyping and really quick down and dirty stuff. But then when I got to looking at porting like Pico or Python Mini or Pico Python, whatever, it's all written in C.
Yeah.
So it was like, so I'm going to compile a C program and load it on here, and then write in a program, a language I'm not that good at and don't particularly care for. So I scrapped that part of the presentation.
Yeah. Like on my Picos, I always run C.
And like I was mentioning earlier too, is you see a lot of, or if you might have noticed a lot of the same files in this project and that project, and with very minor differences. Some of those files are exactly the same that run on the Pi as they do on YAR. And that's one of the real advantages of C is that kind of portability. Now I think Python probably has the same portability, but now you're having to put a Python interpreter on whatever target that you're running, and then then you have the timing issues like the one email here recently with the RC signals. And
the problem-
that would have been, you could have tailored that timing with no more than interrupt latency if you'd have done it in C. So.
One of the problems that like I see is that some sensors come with complete support, and particularly if they're AI type sensors, they come with support in Python, and in C they don't. So
I've run into that.
the being able to turn the Python into C is a major deal, and so you end up having to have something on your in your system that's running Python to handle those sensors.
And that's been one of the real challenges for me with the OD Lite. Like
Yeah.
actually I had an OD. Everything was Python centric.
Yeah,
And I could run the demos in Python all day long. But ultimately I need to integrate that into my C program.
yeah.
And I even looked at, bridging between Python and C and just basically calling out or, writing out to a file from Python and then picking it up in C. And I prefer not to get that ugly, but,
Well,
sometimes it's more about making it work than
Let me ask you this.
architecture.
You mentioned once before that you could decompile using one of your JTAGs that would literally give you the source code. So
Well, no, it'll give you the assembly from it.
oh,
But, yeah.
no,
I mean, it won't give
never
you the source
mind.
code.
Never mind. Yeah. Okay. Okay.
Cool.
So is that it?
That's it for me.
Hey!
We went through it.
Great.
Nicely done.
Nicely done.